Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's the problem for today for exam MAS1, Casualty Actuarial Society exam. You are given the following information. For a group of automobile insurance policies, there are three premium levels, P, 1.1P, and 1.2P. Each premium level corresponds to a state 0, 1, or 2 that is determined by claims filed by the policyholders with movement to the next state taking place at the beginning of the policy term. The transition of policyholders between these levels is modeled by a Markov chain as follows. Current state can be 0, 1, or 2. And with the current annual premium P, 1.1P, and 1.2P, and next state if no claim, one claim, two claims given in the matrix, which is the columns are 0, 0, 1, 1, 2, 2, 2, 2, 2. So for example, if a policyholder is in state 0, the premium the policyholder would pay is P. If that policyholder has a claim, then next year the policyholder would move to state 1 and pay 1.1 for the premium. For each policyholder, the probability of number of claims is no claim 0.5% probability, 0.5 probability 50%, one claim 0.4 or 40% probability, two claims 0.1 or 10% probability. Calculate the long-run mean value of the annual premium. Calculate the long-run mean value of the annual premium. I don't know why I did this, but it's only one question. And here's the solution. The transition matrix between the states 0, 1, 2 is given here as P, and it has columns of 0.5, 0.5, and 0, 0.4, 0, 0.5, 0.1, 0.5, 0.5. Let pi a vector pi consisting of pi 0, pi 1, pi 2 be the vector of long-term stationary probabilities of being in state 0, 1, and 2. Then the balance equations are given by the formula pi, a vector pi is equal to vector pi times p, the transition matrix, or pi 0, pi 1, pi 2 is equal to pi 0, pi 1, pi 2 times the transition matrix. So this is really what this matrix form of the equation translates into. This is the regular system of equations. And from the first equation, we see immediately that pi 0 is equal to pi 1, given that the second equation becomes 0.6 pi 1 is equal to 0.5 pi 2, so that pi 2 is equal to 1.2 pi 1, and of course then also pi 2 is equal to 1.2 times pi 0 because pi 0 and pi 1 are equal. The third equation then becomes equivalent to the second equation with substitution pi 0 equal to pi 1. But that's no problem because we know that these equations are linearly dependent. And the additional equation that lets us solve the system is the one that says pi 0 plus pi 1 plus pi 2 is equal to 1. And that means that pi 0 plus pi 0 plus 1.2 pi 0 is 1. So that 3.2 pi 0 is 1, or pi 0 is 1 over 3.2, or 10 over 32, or 5 over 16. Then pi 0 is 5 over 16, pi 1 is 5 over 16, and pi 2 is 1.2 times 5 over 16, which I just kind of very slowly transition to 3/8. So pi 2 is equal to 3/8. And based on this, the long-run mean value of the annual premium is people in state 0 pay a premium of P, in state 1 pay a premium of 1.1P, and in state 2 pay a premium of 1.2P, and The probabilities of being in those states are 5/16, 5/16, and 3/8. So this is what we get. That's equal to, eventually, 177 over 160p, or 1.10625p. And that's answer B. Please remember, this is copyrighted material. The problem itself belongs to the Casualty Actuarial Society. The solution is mine. Good luck in your studies and good luck on the test.